Welcome to Intro to Trig Identities. Now this is going to be a very basic video on trig identities. So if you need something more advanced, we're going to do another video later. So the basic trig identities that we are going to go over today in this video is we are going to look at the reciprocal identities, the ratio identities, as well as the Pythagorean identities. And so you can see all the identities here, and their names do make sense, right? The reciprocal identity is cosecant equals 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. And then the opposite is true too, right? Sine is 1 over cosecant, cosine is 1 over secant, and tan is 1 over cotangent. And the ratio identities correspond with tangent and cotangent. So tangent is sine over cosine, cotangent is cosine over sine. And then we have the Pythagorean identities. The main one being cosine squared plus sine squared equals 1. So some equivalent forms that you'll see here, sine squared equals 1 minus cosine squared, or you'll see cosine squared equals 1 minus sine squared. And you know, from that we can derive, well, if we square rooted both sides, we could also get a relationship for sine. Same thing here, if we square rooted both sides, we could also get a relationship for cosine. And then we also have 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. So we are going to use all of these identities, but I always thought like identity is not maybe a good word for this. The better word would be relationship. This is how the 6 trig functions relate to each other. So it's a way that we can take what we know, like if we know something about secant and we know the reciprocal relationship of it, we can also extrapolate something about cosine. Same thing in regards to tangent. If we know something about tangent, what does that automatically mean? Well, that automatically means that we also know something about sine and cosine because these guys relate to each other. So the identities are just like a recipe list, basically, hey, this is how these guys kind of all relate to each other. So if you have information maybe about one of them, this is how you can use that information to find out information about the other ones, okay? And again, it depends on what you need. So these are valuable in many different ways, and we're about to see a couple examples. So let's say, for instance, I'm going to write in white on this slide. Let's say, for instance, we knew that sine, the value of sine of theta, is 24 over 25. And we also knew the value of cosine at the same theta was negative 7 over 25. Well, using the ratio identity, we could figure out tangent, right? Why? Because I know that tangent is equal to sine over cosine. So then tangent is equal to, well, sine I know is 24 over 25. And cosine I know is negative 7 over 25, dividing by a fraction, same as multiplying by its reciprocal. So that'd be 25 over 7 and negative. Hey, our 25s are going to cancel out. And then we're going to be left with negative 24 over 7. And now I know the value of tangent, which I did not previously had. But what I did is I used the relationship that I know about sine and cosine and how they relate to tangent in order to figure out the information that I needed for tangent. Again, these are called identities, but I think relationships is a better word for it. So if you know anything about sine and cosine, then you know stuff about tangent as well as cotangent. So let's look at another example. So the other thing I can do with these identities or relationships, let's write in this weird yellow color, is I can transform certain expressions into other expressions using these identities and relationships. So for instance, a common exercise to do is to write things in terms of sines and cosines. Really, if you can get things down to sines and cosines, you're kind of golden, right? Because almost everything relates with sine and cosine. So how could I transform secant of x times cotangent of x. How can I transform this into only sines and cosines? Well, how does secant relate to sine or cosine? Oh, secant is equal to 1 over cosine. Okay, so I transform secant into something over cosine. Okay, how does cotangent have a relationship with sine and cosine? Oh, the ratio identity. I know that cotangent is equal to cosine over sine. So now, multiply straight across the top, cosine x over sine times cosine, right? Which, so again, to review, secant became 1 over cosine. Cotangent became cosine over sine. So now I can knock out my cosines. Oops, sorry, that's a bad knockout. And I have 1 over sine of x. Excuse me. Forgot my x over there. I constantly forget my x's and my thetas, so if you see that, just excuse me. So now I have secant and cotangent in terms of just sine. Done with that one. So the other one is, and let me do this in a different color just for fun. How do I transform now if I have something cotangent over tangent and I need to transform it in terms of sines and cosines? Maybe I only have the values for sines and cosines. But my problem, my issue, my application, whatever, is giving me cotangent over tangent. Now I need to interpret this kind of in what I have or what I know. So, and suppose I only know sines and cosines. So how can I take cotangent over tangent and, change it into sines and cosines? So cotangent, what do I know about cotangent? Well, same thing that I already knew. I know that that is cosine over sine. What do I know about tangent? Well, from the ratio identity, I know that I know that tangent is sine over cosine. Okay, dividing by a fraction, same as multiplying by its reciprocal. So let me take my denominator and flip it, cosine over sine. Multiply straight across the top, straight across the bottom. So I have cosine squared in the numerator, and I have sine squared in the denominator. Now my only job is to rewrite it in terms of sines and cosines. So I would just be done here as well. I'm not trying to make it into anything else. I just need to make sure when I finish I have sines and cosines, and I do. So I'm done with that. So again, another example of how these trig functions relate to each other. They're all interconnected. They interrelate, okay? And that list of identities that we saw on the first slide is what we can use now to transform all these other things into what we want. So another thing that we can do is we can show that certain things can transform into, so certain combinations of the trig functions can transform into other trig functions. So I'm going to prove in this example that cosine times tangent is actually equal to sine. So whenever you're trying to prove something about trig identities, I'm either trying to make the left side look like the right side, or I'm trying to make the right side look like the left side. So what would be easier for me to do is I'm going to work with the left side, and when I'm done, I want to make the left side equal sine. Exactly. So how could I do that? Well, cosine of theta, I'm just going to kind of leave. But I know that tangent is equal to sine over cosine. Right, I just transformed tangent into sine over cosine using the ratio identity. Now when I multiply these two guys together, hey, I notice that, okay, well now my cosines knock out. I am now left with sine over 1. That is equal to sine. So I did it. I made my left side match my right side just by using relationships and the trig identities. And that's it. Let me do another one of these. So what about maybe something a little more complicated? How could I make tangent plus cotangent turn into secant times cosecant. And you can either work with the right side or with the left side. I'm just going to continue working with the left side, but anytime you see one of these problems, you kind of have to evaluate for yourself, and everybody's different, and everybody's going to kind of see different things right off the bat. You kind of have to look, evaluate, and be like, okay, what side do I think might be more efficient or easier for me to work with? In my case, I'm looking at this left side here, and I'm already seeing that I can transform this in terms of sines and cosines, which is kind of always what you want. If you can get everything down to sines and cosines and work with it that way, that tends to be the easier route to go. So tangent, I know, is sine over cosine. Cotangent, I know, is cosine over sine. So that's my goal. I'm trying to get this over here. Okay, I need to add these two things together, right? Because these are being multiplied by each other. So let me combine these. And I'm just going to use what we know about fractions. Well, I need a common denominator. Well, if you have two denominators that are relatively prime, how do you get a common denominator? You multiply them by themselves. So I'm going to multiply top and bottom here by sine. I'm going to multiply top and bottom here by cosine. So when I do that, I get sine times sine over here. That's going to tell me sine squared. In my denominator, I get sine times cosine. Okay. Cosine times cosine is cosine squared. And I have the same denominator now. Sine times cosine. Great. So when you have two fractions and you have the same denominator, what can you do? You can combine their numerators. Awesome. So I got sine squared plus cosine squared up here in my numerator. And I have sine cosine in my denominator. Hey, I'm going to use the Pythagorean identity here. I know that sine squared plus cosine squared, according to slide 1 under Pythagorean identities, sine squared plus cosine squared equals 1. That is like one of the most famous, most used trig identity. Cosine squared plus sine squared equals 1, or sine squared plus cosine squared equals 1, right? Commutative property. All right, sine squared plus cosine squared equals 1, according to Pythagorean identity. Awesome. So I have sine times cosine down in my denominator. Now I want to split this. So 1 over sine times 1 over cosine. That was legal, right? If I multiply this back together, I'd get 1 times 1 on the top, and I'd get sine times cosine on the bottom, so I could split that. All right, well, what is 1 over sine? 1 over sine is better known as cosecant. What is 1 over cosine? 1 over cosine is better known as secant. And I'm done because of, again, commutative property. Cosecant times secant is the same as secant times cosecant. Boom, done. Made that look like that. Okay, again, using trig identities in here, I just used a little bit of fancy algebra just to combine my fractions, but that was it. So one last thing that we can do, or that is available to us, just like you saw, so I'm going to kind of break down even more so the step that you guys just saw, that subtraction or addition step. You can add or subtract trig functions. You can add or subtract anything as long as it has a common denominator. So what if I want to combine these? Right? Anything is itself over 1. Okay, well, I need a common denominator here. Well, I have sine here and I have 1 here. So what could I do? I could multiply this fraction by sine over sine. Right? And if I do that, I still have 1 over sine on the left because I didn't touch that. I have sine squared now because sine times sine is sine squared. 1 times sine is sine. Hey, I have two fractions and they have same denominator. Awesome. 1 minus sine squared is now my new numerator. That's a 2. Over. Now, remember when you're combining fractions, the denominator just stays. So 1 minus sine squared over sine. Hey, let me use the Pythagorean identity again. 1 minus sine squared transforms into cosine squared. So, and I'm going to leave this alone now the way that it is. So I subtracted these two terms. I got a single term, as well as I simplified it again using, once again, one of the Pythagorean identities, like relationships, right? If you have cosine squared plus sine squared equals 1, the other thing that you have then is you have cosine squared equals 1 minus sine squared. This is just by subtracting sine squared on both sides. Or I could have subtracted cosine squared on both sides, and sine squared is equal to 1 minus cosine squared. All of these are related. So thank you guys for playing along with me so far. I hope that was helpful, and I hope it was informative. As always, if you have any questions, please don't hesitate to ask. If you need to find me or more about me, I'm the girl at the mathtattoo.com, and I'm always available to answer any questions you may have.